Um, can you hear me?
Yes,
Humble yourselves for the prayer. Oh, Heavenly Father, God above, thank you for bringing us here with your love. Thank you, God, for everything. May you protect us and guide us through this lesson. Jesus' name we've prayed, amen.
amen. Teacher Peter, you're most welcome. The floor is yours.
Okay, thank you, Ruth. Hope you are all hearing me well before I start unmuting people. Are we all hearing?
We are hearing.
Okay, good. I greet you all and I thank you for keeping time today and coming in such big numbers. For those friends who have joined us today, last week we had a lesson, and that lesson was about introduction to current electricity. And as we are introducing ourselves to current electricity, we talked about cells. And by the time our lesson ended, we had talked about a simple cell. So whoever was not there, there are things that you need to know. I think my friends will be helping me to tell us what they remember about the things that we discussed. For example, we discussed that in order for us to understand cells, we must know about 2 or 3 things. First, we need to know what potential is, electric potential. Then we must know what potential difference is. And after knowing what potential difference is, we need to know what we call EMF, which is the electromotive force. And after we talked about EMF, we talked about types of cells, and we started with the primary cells, where we saw the simple cell, how it works, and the defects in that cell, and how we can get rid of those defects in the cell. So for these first 10 minutes, we are going to help our friend who didn't attend the first lesson at least have a hint on what we covered in the first lesson by reminding ourselves of what we covered. I will start with the asking if there is anyone who remembers what we discussed in terms of definition for electric potential. How did we define electric potential? Anyone? How did we define electric potential? Anyone to give us a definition? You can raise up your hand and you give us your answer. How do we define electric potential?
Okay, let me give the answer. Electric potential is the work. Let me first read down in the chat. From Michael Blair, he says electric potential is the transfer of charges from one point to another in a circuit. And then I think what I recall is that electric potential is the work done to move a column of charge from the earth to a point. Then from Emi, what's your view?
Okay. Well, electric potential is the amount of work needed to move a unit charge from a reference point to a specific point against an electric field. That is how I define it.
From Ingrid says we defined it as work done while moving a column of charge from the earth to the point. Then Paul says it is the work done per column in bringing positive charge from the earth to the point. Then from Maria, she says electric potential is the amount of work a net charge. Okay, I didn't get that from a reference point. Then Charity says it is the work done to move a charge from one point in another in an open circuit. I think one point to another in an open circuit. And lastly, from Daisy.
Electric potential is the work done to move a charge from one point to another, and possible when two charges have different abilities.
Okay, thank you all for those answers. We defined three things that day. There was one, electric potential, two, potential difference, and three was EMF. So we defined electric potential as work done to move. Some people can say a positive column of charge. Other people can say a unit charge. Whenever you say a unit, we said column is the SI unit for charge. So a person who has said unit charge, a column of charge, a positive column of charge, all of us are still in the same position. So work done to move a column of charge from the earth. Now, our friends have called that reference point, which is also correct, but you should be specific on which reference point are you talking about. Now that we are talking about current electricity, this reference point should be the earth. So the work done to move a column of charge from the earth to a point in an electric field, one of our friends added against electrostatic force. It's also fine, but for our level, as we are, it is okay if we stop at that. Work done to move a column of charge from the earth to a point in an electric field. What you have there is the definition for electric potential. But we can also have a definition for another quantity, which we talked about, and the quantity is potential difference. So how do we define potential difference?
Maria, your hand went up first.
Potential difference. Hello.
Please proceed, it's okay.
Potential difference is the amount of work done in moving a unit positive charge without acceleration from one point to another.
Thank you. And then Timothy.
Potential difference is a potential developed while moving a charge from one point to another in the field itself.
Thank you.
Yeah.
And then Joel. Joel, you're not unmuting. Okay. Amy.
Well, potential difference is the amount of work done in moving a unit positive charge without acceleration from one point to another along any path.
Then lastly from Delin, sorry. We cannot hear
Potential
you,
difference
pardon.
is moving a column of charge across the terminals of a cell. Potential difference is the amount of work done in moving a column of charge across the terminals of a cell in open circuit.
Okay. And I think that's it.
Okay. We define potential difference. We said potential difference is like you're having 2 points whose potentials you know, and then you have to get the difference between their potentials. So we defined the work done in moving a column of charge from one point to another in an electric field as the potential difference. Then lastly, in our definitions, we are going to define EMF, or the electromotive force. How do you define EMF?
Timothy, your hand is up. Did you forget it up by mistake, or you have the answer?
So basically, electromotive force is the electric potential produced by either pardon? Now I'm like, an electromotive force is the electric potential produced by either an electrochemical cell or by changing the magnetic field.
Okay, thank you. Then Maureen and Patience.
An electromotive force of a cell is the potential difference across the terminals of a cell in an open circuit.
Okay, then in the chat, Ingrid has the same answer. It is the potential difference across the terminals of a cell in an open circuit. Then lastly, okay, let me see. Al says electromotive force is work done in moving a column of charge across the terminals of a cell in an open circuit. Daisy and Priscilla, are those the same answers you have? Daisy, okay, you can proceed, teacher.
Okay. We said EMF, which is the electromotive force. We defined it as the work done, or we briefly, let me say, it was potential difference across the terminals of the cell in an open circuit. So we said, if someone is open circuit, it means that cell is only connected to an instrument that measures the potential difference. So it is from the cell, maybe to a voltmeter. So if it is across terminals of a cell, we call that potential difference EMF, which is electromotive force. We said it can also be defined as the work done to move a column of charge across the terminals of a cell in an open circuit. And I said, if we say open circuit, we mean a circuit where the cell is only connected to a measuring instrument. That is what we said about EMF. So those are the main definitions that we looked at. And after looking at these definitions, we went ahead to look at types of cells and their examples. So types of cells that we had. Can anyone remind us of the types that we had? Anyone remind us? Yes, Patience?
Primary and secondary cells.
So we had cells which are primary, and we had cells which are secondary cells. So we had both primary and secondary cells, and each of these ones had examples. So can someone give us examples for the primary cells?
Daisy. Okay, let's hear from Liz. Muévase.
Secondary cell.
Primary examples.
We have simple cells.
We have
A simple cell.
a simple cell.
Then from Enid.
We have a simple cell.
We have a dry cell.
We have a dry cell.
And Priscilla.
Laplacian wet cells.
And the wet cells. Then for the secondary cells, which types did we have for secondary cells?
Priscilla, your hand is still up. Okay, let's hear from another person. Sharia.
Alkaline cells.
Timothy.
We have lead acid cells, lead acid batteries,
Lead acid
batteries,
and
alkaline,
okay. So we have the lead acid and we also have the nickel alkaline. I think that is what we had.
Mary, your hand is up.
Had
According
the
to my
lead acid cells.
research, amongst that examples of primary cells, they're also button
They're also
cells, the ones in the wristwatches and scientific calculators.
okay. So we have the leads and lead acid and the alkaline cells. So those are the types that we looked at. And we looked at a simple cell first because we had to look at each of them in a bigger way. And we started with a simple cell. For those ones who are there, what makes a simple cell? First of all, what makes a simple cell? How can we make a simple cell? If there are any hands.
In the chat, before we go to the hands, let me see. Okay, Ingrid says a simple cell is made up of electrodes. Then electrodes still from Joan Perscovia cell says 2 electrodes and an electrolyte. Shaba. Sharia, they're saying you choose it.
A simple cell is made up of electrodes that are dipped in an electrolyte and are connected by a piece of connecting wire.
Okay, so that means that for a simple cell, we have 3 things. We have a connecting wire, we have electrodes, and we have an electrolyte. And we said electrodes must be metals, first of all, and the anode, which is the positive electrode. What did we say about anode and the cathode? What characteristics should they have? What characteristics should the electrodes have?
What I remember is that the anode is the most should be the most the anode in the reactivity series is the most reactive. So that is to say zinc, which forms, oh my God, I'm lost. So the anode is the most reactive metal, and then the cathode is the less reactive. I don't know if
Sure.
I've brought it out
Which
right.
of the two anode and the cathode should be most reactive?
The anode.
Which is the positive?
Yes.
Okay. Let us see if not forgotten what we were told.
Prayer. Has not admitted.
Okay. Here we say that a simple cell is made of electrodes. The positive electrode, the positive is the anode, not so? And the negative electrode is the cathode, and they are dipped into an electrolyte. So the more the more reactive metal in the reactivity series, I want someone to read for us this. Which screen are you seeing now, Ruth?
I'm
The
still
one for
seeing
the
the
notes or
whiteboard.
you are seeing the whiteboard?
Yes.
Okay. Let me share this other one. Should read for us that, and after that we will go to the next thing in our lesson today. Who is reading for us about a simple cell?
Alvan.
As I start from simple cells.
Yes.
Okay. Simple cells. A simple cell is made up of electrodes, i.e., a copper rod, in brackets positive electrode, and zinc rod in brackets negative electrode, that are dipped into an electrolyte in brackets dilute sulfuric acid and are connected by a piece of conducting wire. The reactive metal in the reactivity series has to say, i.e., zinc forms the cathode, while copper forms the anode. The electrolyte being the electrolyte being, and then they show this formula.
Okay. We see that the one that reacts fast forms the cathode, and the one which takes long to react forms the anode. So the more reactive reactivity series forms the cathode, you note that, and the less reactive forms the anode. With our positive electrode. The positive electrode is called the anode. The negative electrode is called the cathode. That is how a simple cell is. So today I don't want us to discuss simple cell. It may take us a lot of time. Again, I want us to look at a dry cell. I want us to look at a dry cell.
Maybe, teacher, before we move to another aspect, Preshi and Peter Claver, something like your hands are still up. Do you have questions, or you can lower them? Preshi, your hand is up. Do you have a question? Or you forgot it?
I have a question. There is a part on the simple drive and simple cells where you are reading something to me to you. Yeah. There is a part on the simple cells where they say that it is dipped in the electrolyte, and in the whiteboard they told us that we are connected. It is dipped and connected by the wires. So can't I just say it is dipped in an electrolyte and I stop there? Or should I continue and say connected by a wire? So teacher, please correct me on that.
Okay, now we have two different we have let me first let me share. Now we have maybe if this is our electrolyte, we have two things. There is a cathode, which is in our question copper, and there is also we have a cathode and we also have anode. So the anode is the copper, which is a positive electrolyte, and the cathode is zinc, which is a negative electrode. Now, our electrolyte is the sulfuric acid. What we do is we dip our electrodes in the electrolyte at different points. Now, what happens is that what we are interested in is to have electrons move from the negative to the positive. But the only way the electrons can move from the positive to the negative is, from the negative, sorry, to the positive is through the connecting wire. Because what passes through the electrolyte are other ions. For example, we said that the zinc ions will have to react with the sulfate ions from the high sulfuric acid, which is dilute, and when they react, they will form zinc sulfate. Now, since the zinc ions are reacting, they will displace the hydrogen ions, and the hydrogen ions will move through the electrolyte to the copper, which is a positive, to the copper, which is our positive electrode. So what happens is that as the zinc, because it's a solid, as it changes to iron, as we change from zinc metal to zinc ions, there are electrons that are given off. And those electrons can't move directly through the electrolyte. So the reason why we connect a wire from the negative terminal to the positive terminal is for those electrons that have been given off as the zinc solid reacted, is to move the electrons to the positive electrode, such that those electrons that go to the positive electrode meet with these hydrogen ions that were displaced by the zinc ions in the electrolyte to form hydrogen gas. And that hydrogen gas, we see it by bubbles of the hydrogen that are made at the copper electrode as our process continues. So we have to have the electrolyte because of what it does, and we have to have the connecting wire. So as our electrons may move from the from the negative electrode to the positive electrode. And it is on this connecting wire that we can even connect a measuring instrument such as a voltmeter, such that when it deflects, then we can tell that there is current that has been given off by this cell. What can do that is if we have connecting wires connecting the negative to the positive. So we can't have a cell complete if we don't have the connecting wires. Hope I've answered you, my dear friend.
Mr. Nsubuga, in the chat, there are two people who are lost. Joan, I think they have just joined us, but I request we proceed with the next aspect so that they can find the recording of the previous lesson and then the notes on the group.
Okay. All right, we continue with the examples of primary cells, and some of the examples we have finished looking at a simple cell in details. So let us look at dry cells. Now, in case you miss any lesson, in case you missed any lesson on any day, you can just go to the help YouTube channel and you watch those lessons. And after watching them, you can link them up with the ones that you have attended. And I'm sure you will have a good time. Now, a dry cell also has a positive contact and it has a negative contact also. And a dry cell, they are telling us, it uses a wet paste of ammonium chloride as the electrolyte. The anode is a carbon rod surrounded by a mixture of powdered carbon and manganese dioxide, which are placed inside a zinc container, and the zinc, which is outside, forms the cathode. So that is what makes a dry cell. Let me see if we can get a video that can give us everything about a dry cell and how it's formed.
Mr. Nsubuga, I request you share with audio because we're not hearing anything.
But you are seeing the video, right?
Yes.
Are you hearing it now?
Mr. Sugo, where you go to when you share the screen, you go tap the icon of share screen and then you say share with sound.
Which serves as the negative
Okay, now we are
electrode.
hearing.
Okay.
Dry cell. The dry cell is a modification of the wet Leclanche cell in which the ammonium chloride solution is replaced with a jelly composed of starch, flour, and ammonium chloride. A mixture of manganese dioxide carbon surrounded an electrode cupboard placed inside the can, which serves as the electrode. The space between the central core and the can is filled with the ammonium chloride. It's drying up by sealing the top of the cell with pitch. A cardboard washer is used to prevent the carbon rod from coming in contact with the zinc can. The zinc can is surrounded by an insulating thick paper covering. The working of the cell is similar as that of the wet Leclanche cell. The EMF of this cell is about 1.5 volts. It is portable and used in torches and transistor sets, etc.
Okay. We have seen a dry cell, its composition from the inside. Maybe I could replay the video once more such that we can see the composition of that cell properly.
Dry cell is a modification of wet Leclanche cell. Dry cell batteries are different from wet cell because the electrolytes are contained in a low moisture base. A dry cell consists of a zinc container. Base acts as the negative electrode or anode. The carbon rod placed at the center with a brass cap acts as the positive electrode or cathode. This is surrounded by a mixture of manganese dioxide and charcoal in a muslin bag. The electrolyte used is a moist paste of ammonium chloride. The outer body, excluding the base of the zinc container, is insulated with cardboard to prevent graphite rod from coming in contact with zinc container. Working of a dry cell. When the dry cell is connected in a circuit comprising a bulb, current flows in the circuit due to the chemical reaction that takes place in the cell. This makes the bulb glow. The rod in the dry cell battery has two terminals, one that is positive and one that is negative. When a bulb is connected to the battery's terminals, a chemical reaction occurs between the electrode and the paste that produces roughly 1.5 volts of electricity. The electricity produced is conducted out of the battery with the help of an external circuit.
Okay. That there was trying to show us what a dry cell is composed of. So they have told us many things, but they have talked about the carbon rod being the cathode and the zinc can being the carbon rod being the anode and the zinc container being the cathode. And they have told us that inside the electrolyte that is used is a mixture of powdered carbon and manganese dioxide, which is placed in center of a zinc container. So they have given us the composition. You as a person, what you have to know about a dry cell is what makes a cathode, what makes and how do these ones move? I told you what you have to know as a person is what makes the electrolyte, what makes the anode, and what makes the cathode. We have seen that the electrolyte is ammonium chloride mixed with some powdered carbon, and they have told us the reason why they mix it with powdered carbon such that it keeps in jelly form, such that it does not dry out. That is what the powdered carbon is used for. Then the anode, which is a positive electrode, is made of carbon, whereas the negative electrode, which is the cathode, is made of zinc. How does this work? We are going to read about the action of a dry cell. So I'm going to request one person to read it for us. How does the dry cell work, or action of a dry cell? Can I have any person to read it for us?
Okay. See, Divine.
Action of a dry cell. The source of energy is a chemical action between zinc and ammonium chloride jelly. As a result, hydrogen gas is produced which collects at the carbon rod and polarizes the cell. The manganese 4 oxide oxidizes the hydrogen to water in the cell and enables it to supply current for some time.
You read again, slowly.
The source of energy in a chemical action between zinc and ammonium chloride jelly. As a result, hydrogen gas is produced which collects at the carbon rod and polarizes the cell. The manganese 4 oxide oxidizes the hydrogen to water in the cell and enables it to supply current for some time.
Okay. They have told us that what makes this dry cell produce energy is the chemical reaction between the zinc and the chloride jelly. This one here. So the zinc, which is our cathode, reacts with the ammonium chloride jelly, and as a result, hydrogen gas is produced. Someone may ask, how is the hydrogen gas produced? The hydrogen gas will be produced from the ammonia. Because ammonium chloride has some hydrogen in it, ammonia is the NH4, where N is nitrogen, H is for hydrogen. So from the reaction between zinc and ammonium chloride, we'll be having some hydrogen being given off. And the hydrogen that is given off collects itself at the carbon rod. And when it collects itself at the carbon rod, it polarizes the cell. So someone may ask, what is polarization? When we were studying the simple cells, we said that one of the defects of a simple cell is polarization. And we defined polarization as we said this is where hydrogen collects at, let me put that back so, so that we can read it together. If you look at our polarization as the collection of hydrogen bubbles at the anode, which partially insulates it from the electrolyte. So, if you are quick enough, someone can write it in the chat such that in case anyone asks it, we can look for it in the chat. Collection of hydrogen bubbles at the anode, which partially insulates it from the electrolyte. So since the hydrogen gas is coming to collect at the carbon rod, it means that it will first insulate the carbon rod from the electrolyte, which is ammonium chloride. That means our cell will be polarized. So what helps us is that in this dry cell, we have manganese 4 oxide in our mixture of carbon. And that manganese 4 oxide, why it is there in a cell, is to oxidize the hydrogen. Oxidizing means it gives out the oxygen to the hydrogen. And when hydrogen and oxygen get together, they form water. And when water is formed in the cell, because water is something that can conduct electricity, that's why they have told us that it enables the supply of current for some time. So that is how a dry cell works. Any question before we continue about the working of a dry cell?
Rishi, your hand is up. Rishi, unmute. Okay, let me see any questions in the chat. Someone is asking, could you please repeat the use of manganese?
Okay. Manganese 4
Then
oxide.
others are asking,
Yes, others are asking what? You finish.
that you repeat the explanation of polarization.
Okay.
Though I've already sent in the definition.
Okay, fine. Now, first, let me start with polarization. Now, they have told us that when zinc and ammonium chloride react, there is hydrogen gas given off. That hydrogen gas that is given off will collect at the carbon rod. Now, when hydrogen collects at the carbon rod, it insulates the carbon rod from the electrolyte, which is the ammonium chloride. Insulating means it separates, it creates a boundary between the ammonium chloride jelly and the carbon rod. And when the boundary is there is nothing that can take place. So when the hydrogen comes and creates a boundary around the carbon rod, that boundary, that creation of that boundary is what we call polarization. The collection of hydrogen around the carbon rod, which separates it or which insulates it from the ammonium chloride. That is what we call polarization. Now, because we don't want polarization inside the cell, as they are making this cell, they mix dry carbon, I think somewhere here in our diagram, you see that we have a mixture of powdered carbon and manganese 4 oxide. The use of, I told you, dry carbon is to keep our ammonium chloride in jelly form. Jelly form means that when it is not too hard and it's not watery, but in jelly form, what keeps ammonium chloride in that form is the powdered carbon. Then the use of manganese 4 oxide is to oxidize, is to give off, is to give away the oxygen it has to the hydrogen that is collecting around the carbon rod, such that when they react, they form water. And water being a conductor of electricity, because electricity can go through water, it will enable the current to be supplied throughout the cell to the outside, of the cell, or to the outside parts of the circuit where that cell is connected. So that one there is how a dry cell works. So someone may ask, yes, if
Paul
if
is
the-
asking why use non-metal carbon is
sorry?
But why use non-metal carbon instead of copper for an anode?
Okay, why we use?
Paul is asking why use non-metal carbon instead of copper for anode?
Okay, someone is asking why we use carbon instead of copper. Now, if you look at a simple cell where we used copper, you saw that these two were not how can I bring it? These two needed to react with the electrolyte so as to produce the electricity. For our dry cell to work for a bigger time or a longer time, we need something that will not react with the inside part. Let me get to where I want. Let's see. I'm looking for a way to phrase it such that we can all understand. Now, one of the reasons that we don't use the metals, there are many things that will come up, like corrosion or dissolving inside. Let me try to annotate. Now, there is something that we call corrosion of metals. Now, if our inside our dry cell, we had put something like copper, copper can undergo corrosion and it can sometimes react with the electrolyte. Because the only reaction that we want inside the cell is for the hydrogen and the oxygen to form water. If there is any other reaction that takes place inside our cell, then we won't be able to get the results the way we get them. It means that if they used something like copper, then they had to add a lot more things inside the cell for it to work. That's why I think they came up with carbon. First of all, to make sure that the inside of that cell does not corrode. Does any one of us have a dictionary to tell us what corrosion means? So that we can all understand it. Is there anyone who can give us a meaning of corrosion? But what you have to know, something corroding means it loses its original value with time. For example, if you left a metal piece outside for a long time, there are bubbles. It makes something like a blister. If you check a tank that you have left outside for a very, very long time, at the bottom of that tank, you realize there are things that are developing, such as blisters, and even the paint of that thing starts to move out off. So what happens, what makes that to move off is what we call corrosion, something getting destroyed over time because maybe of the reactions and the other things that take place. So the reason why we don't use metals, one is because of corrosion, and two is because we don't want any other reaction inside the dry cell other than that one between the hydrogen and the manganese for oxide. I think we can take those ones as our definition. So they have told us that a dry cell can produce an EMF, which is about 1.5 volts. And the dry cell has its advantages. It is portable. Its electrolyte is in a jelly form and cannot pour. They are common, so they can be used in many gadgets. That's why it is advantageous over a simple cell. So that is what we could know about a dry cell. Then we have a wet we have a wet Lagrange cell or a Lagrange wet cell, and they have told us that what we had as a dry cell is an advancement of this wet cell. So they first made the wet cell, and from the wet cell, that is where they got our dry cell from. And they are telling us here, can someone read for us what you see on screen about a wet cell? Who is reading for us? Anyone to read for us about a Lagrange wet cell? Who should read for us? Yes, Sharon. Shalom. If you are still there, you can read for us.
Yes. The Lagrange wet cell is identical to the dry cell, except that its electrolyte is liquid ammonium chloride solution. Its positive pole is a carbon plate surrounded by a depolarizing mixture of powdered carbon and manganese oxide in a porous spot. A zinc rod acts as its negative pole. Both the porous spot with its contents and the zinc rod are placed inside a glass jar containing a solution of ammonium chloride.
Okay, thank you for that. So they
Teacher,
are telling us that in a wet cell, the only difference between a wet cell and a dry cell is that here, instead of us using jelly ammonium chloride, we use liquid ammonium chloride. In other words, we use a solution of ammonium chloride. And they have told us that we have, I think you can see all of them. We have a zinc rod. Now there, instead of having a zinc rod in the dry cell, we had a zinc can. Our things inside the cell were all enclosed in a zinc can. But here we have a separate porous pot which has depolarizing mixture. Depolarizing means that a mixture that stops the polarization or that helps to remove hydrogen in our cell, and it's of carbon and manganese 4 oxide. We know why we have powdered carbon and why we have manganese 4 oxide now in cells. So we get a zinc rod separately from the porous pot. Porous means that that pot has some holes in it, which helps those holes which helps the inside things that are inside the porous pot to interact with the things that are outside the porous pot. For example, the zinc, for example, the electrolyte. So that is why we were seeing that we have that pot being porous such that it can interact with the outside of that pot. So they are telling us that in this wet cell, all the reactions are the same as that in a dry cell, except that here we use liquid ammonium chloride. I hope that is clear for all of us. And the limitation we have is that the depolarizing action is very slow, changing from changing from hydrogen to water is very slow. And that means that you can't maintain a steady current for a long period of time like it is in a dry cell. So those ones that we have looked at are the primary cells, and we have looked at them all in their full capacity. So we are going to have something here that we are going to see, and it's a question that I want you people to help me answer. We are going to have like 10 minutes of answering it, and we'll get answers from different people. From what you have heard and what you have seen, you read this question and then give me the answers in the chat.
Technospark, your hand is up. Oh, before you read, you tell us your name, then you can. And allow me pass this picture. If you had sent a message direct to me and your question was not answered, you please resend it direct, because I had to block that chat. I had people who are misbehaving. Michael, please go ahead.
Okay, I think I would tell them the way I would help my team. I'm now answering the question. As a Form 4 physics student, the way I would help my team win is by explaining in the national science competition some of the importances of dry cells over primary cells, and I would give one of the reasons that dry basic gadgets like torches and other machinery.
Okay, any other answer?
Yes, from the chat. Joylyn. Okay. I think this is Ochan. Kenneth, he says, I would choose dry cell because it's portable. Alvan says a dry cell because it is more portable compared to all other primary cells. I think those are the ones coming in from the chat from my side. And then Miriam.
Okay, according to me, I would choose dry cell over other cells because its electrolyte is in jelly form and cannot easily pour, and dry cell is also common.
Okay.
Then Sarah. Okay, before we have Sarah in the chat, someone using some SM says because it's cheap. Then Katrina. Okay, Sarah, please say your answer.
Can you say it's because it maintains its circuit for a long time?
Maintains what?
So said if it can you say that it maintains its surface because it maintains its circuit for a long time.
It maintains its current, not circuit. Circuit is something else. Maybe it maintains current for a longer time. That one is okay. Any other answer?
Okay. Then in that chat, Nancy says it can supply the current for a longer time than other cells. Charlene says more it's more portable but takes a long time to lose current. Then Ekita says dry cell is cheap and affordable. Mary says it isn't. Then she says form it can't easily pour, and then it's more effectively than.
Okay. Yes, the answer would be you would choose a dry cell because of the advantages that we have seen. First of all, it produces a voltage which is around 1.5 volts, which is a very big voltage compared to that. For example, a simple cell can give you. Then its electrolyte is in jelly form, which makes it easy to move without pouring. remember the electrolytes of the other cells, simple cell and the wet cell are in liquid form and they can pour. The dry cell is also portable in the way it was made. It can be made in any size and in any shape. So that's why we say it's portable and it's able to maintain its voltage for a good time compared to the other cells. So for those reasons, every one of us would choose a dry cell to other primary cells as the for any work. We have seen that dry cells are also used in many things, in torches, in watches, in radios. So all many things that use dry cells, we would choose to use the dry cells. So after looking at the dry cells, the other thing that we would look for are the secondary cells. Secondary cells, we said those are the ones that can be recharged or their chemical reaction can be taken backwards. So they can be recharged. You can reverse the chemical reaction such that that's the battery or the cell can work again. How do we do that? We will also have the notes for secondary cells. So we will have to about the secondary cells, but I want to give something for us all to benefit from. I want us to look at
Mr. Sobuga.
yes.
Sorry for interruption. Carol in the chat is asking, is it okay to pour water in a dry cell since it is an electrolyte?
Is it okay to pour?
To pour water in a dry cell.
We didn't say water is an electrolyte, but we said it's a conductor. But the water that you pour in is not even the way we are going to pour it in. How could we pour water in a dry cell? First of all, Carol. And why would you need to pour water in a dry cell? Because the water that works inside the cell is one that comes as a result of the reactions that take place, not as the result not as a result of outside factors. So it is the inside reactions that produce water, and it is that water that is useful inside the cell. Any other question in the chat or any person with a question?
Pepista?
Tell us.
Okay, sir. Are you listening to me? Sir, I was trying to
You
say,
speak up.
is it, I'm speaking, sir. Is it healthy that people are supposed to dry cell into the water in order to gain the
I'm not getting you well. Yeah, your network is on and off.
Trying to say that one is supposed to place it into the water so that it can then. So
Do you mind if you please type your question in the chat so that I can be able to see it? You help me type the question in the chat so that I can be able to look at it and I answer it.
Then in the chat, Millie is saying, where is the wet cell applied? Okay, she's already asking about this one. But then another one is saying, teacher, I see we need chemistry to understand this physics topic. Any comments about this relationship? And Babi, you have a question, please unmute.
Sir, I would like to repeat for me everything for that secondary dry cell or for everything about water there. Can you please repeat it for me?
Oh, the wet cell or the second, and you talk about the secondary cells. Maybe you are asking about this wet cell. Is it what you're asking about?
Let me unmute.
Yes, I'm asking about that one because I've not understood anything about me adding their water, everything about water. That one that you put there, the wet cell.
Okay. Okay, fine.
And then in the chat, Capito Vista has put her question there. She's asking, is it healthy for one to place the dry cells in when they are used up?
No, it is not. Because even if you said that once something is used, once a cell is used up, because they are primary cells, we can't change the reaction. We can't change the reaction. The reaction in a dry cell is irreversible, so you can't do anything on it to change the reaction. These things of you put it in the sun, you place it where, don't work, because once the reaction inside has been finished, then it can't be reversed back. That's why we cannot even be able to charge a dry cell. Someone was telling me yes?
I think that answers just Remy Justice is question in the chat. Or he was asking what makes a dry cell get used up. Then, if sorry for interrupting, someone else is asking, can we make a dry cell at home using local materials?
Dry cell using local materials. No. What I'm sure we can make that can work as a dry cell using local materials is called an air cell. And I think after we are done with all the cells, I will get time and brief you on how to make an air cell. And you can make one that you can try out and use maybe for your projects and other things, but it's also it also uses chemical reactions, though it produces the small currents, but it can be called a cell too because the currents are produced. But dry cell at home, I don't think it will be possible. There is a friend of mine who was asking for where water comes from. Now we said that in a wet cell, what changes between a wet cell and a dry cell? One is that the electrolyte used in a dry cell is in jelly form, whereas the electrolyte used here in a wet cell is in liquid form. And if you see this diagram that we have here, you realize that we have a liquid ammonium solution in our glass jar, like that. Now here, what we do, or what we should know, that in a wet cell, we have, like in a dry cell, we have a carbon rod. You can see it there in red. It is a carbon rod. And instead of having a zinc plate or a zinc jar, here we have a zinc rod. This one here is a zinc rod. Now, what happens is that all the reactions that were taking place in a dry cell are also taking place in this wet cell. The ammonium chloride solution reacts with the zinc, the rod, and they give off hydrogen. So the hydrogen that they give off passes through the pores because they told us that this pot is porous. So the hydrogen gas given off passes through the pores and enters into this mixture, which we called the depolarizing mixture of carbon and magnesium oxide. So when it enters inside here, what happens is that the hydrogen and the magnesium oxide will react to give out a water. And that water is the one that will help that will cause the electricity to start flowing from this wet cell, because water can conduct the electricity. That is what I said about this wet cell. So if we have answered all your questions, Ruth, you help me share the group link for those friends who are not in our groups. Last week I shared the notes. If you don't have them, I will share them again today so that all of us can be at the same point. So
Teacher,
let
in
us
the
do that.
chat.
Mm.
Someone is asking, Douglas is asking, what is the electromotive force of a wet cell?
Any other question?
Then let me see before I come to Charity. Okay. The rest of the questions came in, very many of them for the dry cell.
Okay.
But okay. Anisha is asking, I've heard of cathode rays. Are they all
She had heard of what?
connected to electricity? I've heard of cathode rays. Are they also connected to electricity?
No, she hasn't had that. I've not said that. I think we have not all had that. The only thing we talked about is the cathode, not cathode rays. We have talked about cathode.
Okay.
Cathode.
Then
Or someone was asking for what is the EMF of this. Now, they have told you that one of the limitations is that the action of depolarizing in a wet cell is slow. So because it can't give us a steady current, then it is difficult also to measure its voltage. But I think if you measure it, it is also about the same value as that of the dry cell, though it will keep on fluctuating with time. I think those ones are done.
Then Charity Shalom.
Yes, I have a question.
Mm-hmm.
So now, when the zinc reacts with the, is it the ammonia? I don't know.
Ammonium chloride
Ammonium
solution.
chloride solution.
Mm.
Where exactly does the water go, and how does it
Where?
where exactly does the water go, and how does it transport current to some?
Now we said that the water given off due to the reactions is still inside the cell, and that is one reason why when it accumulates a lot, I will see a dry cell becomes damp. If you have used a dry cell for some time, you see it as it is becoming wet. So what causes that is that water that is given off. When it is too much, then it causes that dampness in the dry cell.
Wait, so the current moves through the water itself?
Of course, water is a conductor. So because it's inside here, the current can move through that water. But when it accumulates a lot, then it will cause the dry cell to become damp and you can't use it anymore.
Okay. So where exactly in the cell does the water collect?
It is inside. It is inside the cell. Let us see. Look at the dry cell. So if you look at this dry cell, it has a mixture of powdered carbon. So remember, the water is uh, formed it's formed around the carbon rod. So when it is formed, most of it will be going into the mixture.
Mm. Pardon?
And the carbon rod, so it will be going volume of. Okay, if I've answered all questions that we had for now, you will allow me stop here. I'm going to request one person to give us a prayer as we close for our lesson for today. So who is praying for us?
Can we ask someone to pray? Okay, let me see. Someone. Imelda Ben.
Okay, let's.
Imelda, you've muted yourself. Good thing we have many hands up. Nancy, you've never said anything.
Okay, let's humble ourselves and we pray. Almighty God, we thank you for the gift of this lesson. We thank you that you have enabled us to attend, and we pray that whatever we have learned here can be able to understand and keep it in our minds, Lord Father. As we are going now out there, may we continue doing more research, and as we come back for the next lesson, may we be equipped and ready to understand. In the mighty name of Jesus, we pray and believe. Amen.
May, thank you so much for attending. Thank you so much for being around. You continue attending the lessons without missing. I'm sure you will go back to school not the same way. Allow me wish you a good evening